if you look at cryptography, okay, cryptography, what is its main goal? Okay, what is its main goal? Does it protect confidentiality? Yes. Does it protect integrity? Yes. How, we will see. Does it protect availability? Maybe not. It only protects the availability. It never makes information, the principles of availability. It doesn't actually, meet it. Cryptography meets the confidentiality and integrity goals. The confidentiality goals, it can meet by using symmetric operations or symmetric cryptography. What is symmetric cryptography? I'll tell you. Okay, but by using asymmetric cryptography, okay, you can meet both confidentiality and integrity goals. Okay, we will tell you what are symmetric crypto systems and what are asymmetric crypto systems. Okay, so what are symmetric crypto systems? Okay, symmetric crypto systems are, you have a information, right? You lock it. The locking action is basically the encryption. Okay, you lock it, it becomes something called a ciphertext. When the information is not encrypted, it is called a plain text. Okay. Now, once you convert this into ciphertext, if you use the same key for locking, and once you're doing a decryption operation and converting ciphertext back to plain text, if you use the same key, right? If you're using the same key, then it is called a symmetric crypto system. You're locking it with the same key and opening it with the same key. Okay, that is the basic understanding of symmetric crypto systems. Then what are asymmetric crypto systems? Asymmetric crypto systems are you have an information, okay, you lock it with one key, okay, you have the ciphertext, okay, this is key 1, okay, and once you decrypt it and you get back the plain text, you do not do it with the key 1. There is another key which was generated, okay, which is key 2. You use the key 2 for decryption operation, okay. Or if you use key 2 for encryption and create it into ciphertext, and you want to do decryption, you have to use the paired key. That means key 1 for decryption. So these two pairs are complementary in each other. Okay, and that's why it's called asymmetric crypto systems. We'll understand their application, how they protect the confidentiality and integrity once you. A Kirchhoff principle says that if there is a crypto system, you are feeding it data, right? And you're taking out encrypted data. This system should be as open system as possible. So that if it's because generally these crypto systems are nothing but mathematical or algorithms. Okay. Kirchhoff's principle says this mathematical algorithm can only be trusted once it is open systems. Keep it as open as possible. Let anyone and everyone break it. Then only you can find the strength of the algorithm. And therefore, you see AES is a open encryption algorithm. Why? Its algorithm is open. If you can break it, other than brute forcing, break it. Even now, it has still not been brute forced, right? Because the computing power required to brute force even AES 128 and AES 256 is way too high. Okay, and that is the principle of Kirchhoff's principle, and that's why you can trust a crypto system only once it is open in nature, and that's why US government comes up with so many competitions to have, you know, crypto systems which are open standards, right? Okay. Now we should know some basic, crypto maths. Okay, uh, it's called Boolean algebra, and we have done this in class probably 10th. But to refresh your memory, we will have some basic Boolean maths to understand cryptography. Okay, first of all is an AND operation. What is an AND operation? So if you have a logical system, okay, which is an AND system, and it has two inputs, A and B, okay, and you have an output called A and B. Okay, that is basically the operator is AND. Basically, you do a multiplication. So if you make a logical table, okay, and you will have, if you have two inputs, you will have four variables, right? So you have A, B. So first option is you have 0, 0. The operation is A into B, right? A into B. So A into B is generally 0. Then 0 into 1, again 0, 1, 0, 0, and 1, 1, 1. So what does the implication means? If you are building a digital system, if your 0 is equal to 5 volts and 1 is equal to, sorry, if your 0 is equal to minus 5 volts and 1 is equal to plus 5 volts, okay, if this is the denotation, why? Because electronic systems, they work on voltages, right? So that means if you apply a minus 5 volt here, what is the interpretation? That you are applying a 0. And if you apply another minus 5 volt here, your interpretation is this is 0. What will be the output? Output will be 0 into 0 minus 5 volts. Now electronic systems work on this interpretation. Electronic system don't understand 0. You have to tell them what is 0. So you are saying 0 is minus 5 volt, 1 is plus 5 volt. If you apply a plus 5 volt here and a minus 5 volt here, output will still be minus 5 volt for a AND system, because it's a multiplicative system, right? Now, if you apply a plus 5 volt here, that means the system checks it as 1 and 1, and the output will be plus 5 volt and 1. So similarly, you have something called OR operation. OR operation is nothing but A plus B. Okay. So you can do that. And then finally is something called the NOT operation. NOT operation is A is equal to, it's got only one system. Excuse me, let me clear it. OR is A plus B, right? So you have 0, 0, 0, 1, 1, 0, 0, 0, or 1, 1. Right? 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1, right? So if you give an input, that will be the output. Similarly, final is NOT. NOT is the reverse. Whatever is A minus, A reverse, right? So if it is 0, it will be 1. If it is 1, it is 0. So basically, electronic systems are built like that. And one final mathematical function which actually puts crypto systems into action is called an XOR operation. Okay, XOR operation is denoted by A, B, A plus B with a circle, right? So what XOR operation does is, okay, if A is 0, B is 0, A is output is 0. If A is 0, B is 1, that means if these two are alternate, then the output will be 1. That means if the input to a system are two different inputs, okay, the system which we made, if there is a minus 5 volt and there's a plus 5 volt, the output will be 1, that is plus 5 volt. Okay. Next is 1 and 0 will again be 1, But if the inputs are both same, the output will be 0. Okay, this is called XOR function, and it's used very highly. It's actually the entire crypto systems is based on XOR operations. Okay, and finally is something called a modulo function. A modulo function is a mathematical function, basically the remainder of the function. Okay, so if you want to say, represent a number x and y with a mod function, you generally represent it with x mod y, which is nothing but x divided by y. Okay, and whatever is the remainder is the mod. Okay, so if it is, say, you say ask someone what is 8 mod 6, 8 divided by 6, 6 on the 6, remainder is 2. That is the mod. Similarly, if you want to say, 10 mod 3, right? What is 10 mod 3? 10 mod 3 is nothing but 3 3 is a 9, mod is remainder is 1. So this is how you do modulo function. It's called a modulo function. What is the remainder function? How it applies to maths, we will see later. Okay, mod functions are basically saying if you do a mathematical operation, whatever is the remainder, you get some value out of it. Okay, one more thing which we see in cryptographic systems is called one-way functions. What are one-way functions are? One-way functions are, you have a mathematical system, you give it an input, okay, it gives you a fixed length output. Okay, one-way functions are used for hashing. That means once you give an input, it will have fixed length output. But the moment you change input even by a fraction, okay, if you change the input and you change the parameters of the input, the output will change. Output will be different. Okay. And it is irreversible. It cannot go back. This is used in the pretext, in the concept of proving integrity. We will see how. Okay. Now, if you want to try all this out, go online and try to, there are web applications, beautiful web applications people have created to understand these concepts. Okay. If you want to understand hashing, they will say, okay, input, it will give you hash. Now you change the input even slightly, you will see the hash changing. Okay. So hashing functions are mathematical functions which help you to tell you that the hash of this function is constant. So if the hash changes, means the input function has changed. Okay. So it may help you in proving, it will help you in proving integrity. Then you have a function called nonce. A nonce is an abbreviation for number ones. Okay, number ones is basically used in cryptographic functions as initiating variables, IVs. What are initiating variables? Once you do maths, right, and you have an input system, you say you want to encrypt something. So here you are giving the encryption data, right? This is 1001, you want to encrypt it. But the encryption action has to start somewhere, right? First value. The first value is given by a random number, which is a nonce, number one, to start the encryption process. Generally, it's called the IV. This is going to be XORed with the input data and be given the next. You will get some kind of a value, which will again be put into another mathematical system. And again, you will get some, data from somewhere to, and this will be the next input data, right? And then you XOR it. And this is how generally encryption happens. So what happens is, but you need the first initiating variable from where to start. And that's where number ones, nonce, comes into picture, right? Now, what happens is, cryptography helps you in, establishing proof. Okay. What is proof means that, if I have the key, means I am probably the owner of the data, right? say there are two people, right? In internet, right? Nobody knows anyone, right? But you have to prove some kind of a proof. Now imagine you have a door, you have an application, you know, which needs to, you know, give access. Now, there are many ways that you can give access to this application, right? This application gives access to something critical, right? Okay. Now, if you want to, you know, if you want to see that who is the guy who should be given access to this application, right? Then you have something called a zero knowledge proof concept.
Thank you for watching. Don't forget to subscribe our channel.